All right, let's talk about something that's becoming more important every single day. How do we actually know if an AI is any good, or even if it's telling the truth? We're going to look past all the hype and talk about the real hero of the AI world, a little something called evaluation. Let's dive in.
And let's just get this out of the way right up front. The stakes here are incredibly high. This isn't about an AI getting a history question wrong. This is a real headline. It's a tragic reminder that when these systems fail, the consequences can be devastating. So yeah, this stuff matters.
So, how do we stop these horrible failures from happening? Well, the answer lies in this field called evaluation. It's basically the science of testing and grading AI models. You could say it's our single best tool for making sure AI is safe and reliable. But it's also the part that almost everyone overlooks.
And if you talk to any developer who's actually building with this tech, they'll tell you this is a huge problem. It's one thing to build a cool AI demo, but it's a whole other beast to prove that it actually works safely and reliably. Honestly, that evaluation part can end up being most of the work. It's a massive bottleneck.
Now, the good news is that people are starting to wake up to this. We're seeing this absolutely explosive exponential growth in open source projects, all focused on evaluation. The community is finally starting to realize just how critical this piece of the puzzle is.
But here's the catch. Even with that growth, you can see here that the effort going into evaluation tools is just dwarfed by the money and time poured into the sexier parts of AI, like training bigger and bigger models. It's kind of like we're building these incredibly powerful race cars, but we're forgetting to invest in the brakes.
Okay, so to really get how we grade these things, we have to start with the basics. Let's pop open the old school toolkit and see how we traditionally measured the language models that are at the heart of pretty much every AI you use.
The classic metric is something called perplexity. Now, it sounds complicated, but the core idea is pretty simple. It's a measure of how surprised a model is by the next word in a sentence. A low perplexity score is good. It means the model's really confident about what comes next. Here's a simple way to think about it. A good model with low perplexity has seen so much text, it just knows that after I like drinking, the word tea is a pretty safe bet. The word charcoal, on the other hand, well, that would be very, very perplexing. It's all about how well the model learned the patterns in its data.
But here's the thing. Just predicting the next word isn't enough anymore, right? We're asking AI to do really complex jobs, like writing code or summarizing research papers. And for that, we need new tactics to figure out if what it's producing is actually correct.
The most direct way to do this is something called functional correctness. It's as simple as it sounds. Does the thing it made do the job? If you ask an AI to write some code, you don't just look at it and say, yep, looks like code. No, you run it, you test it. If it works, great. If it breaks, it fails. It's totally black and white. For tasks that are a little more subjective, we often have to compare the AI's answer to a perfect reference answer. And there are two main ways of doing this. The old way is lexical similarity. Basically, you just count how many words are the same. But the modern, much smarter way is semantic similarity, which asks, do these two things mean the same thing? And this is the perfect example of why just counting words fails so badly. These two sentences are almost identical, letter for letter, but that one tiny comma changes everything, right? One is an invitation, the other is, well, it's cannibalism. This shows you why understanding meaning is what really counts. Okay, so this brings us to the really cutting edge and, yeah, kind of controversial solution people are using today. What if we just use another really powerful AI to grade the answers for us? Welcome to the wild world of AI as a judge. I mean, that's the big question, isn't it? It feels a little weird, kind of like letting students grade their own tests. Is this a brilliant, scalable solution to our problem, or are we just building a massive echo chamber? Well, get this. The data is kind of shocking. A major benchmark found that GPT-4's judgments matched what human experts said about 85% of the time. But here's the wild part. The agreement between two different human experts was only 81%. So in some ways, the AI judge was actually more consistent than we are. So you can totally see the appeal, right? Using an AI judge is way faster, you can scale it up to check millions of answers, and it can be cheaper than hiring an army of humans. But, and it's a big but, the downsides are serious.
They can be inconsistent, they're full of hidden biases, and using the best models as judges can get really expensive.
And these biases aren't just a theory, they're very real. We know models have a self-bias. They think their own style of answer is the best. They have position bias, where they often just pick the first answer they're shown. And there's a really sneaky one called verbosity bias, where they get fooled into thinking a longer, wordier answer is better, even if it's total nonsense.
So with all these different ways to measure things, how does the AI world actually decide which model is the best one right now? Well, that brings us to our final stop, the model leaderboard. Think of it like the final arena where AIs go head-to-head. The process is actually pretty simple. You give a prompt to two different AI models, but you don't know which is which. They both give you an answer, then an evaluator, which could be you, me, or another AI, picks which answer they thought was better. You do this thousands and thousands of times, and a clear ranking starts to emerge. And if this sounds familiar, it's because this whole idea is borrowed directly from competitive games. It uses rating systems like the ELO system from chess to calculate a score for each model. So if a model beats a higher-ranked opponent, its score goes up. If it loses to a lower-ranked one, its score goes down. Simple as that. And the end result of all those matches is something that looks just like this. A nice, clean leaderboard that gives you a pretty good snapshot of who's on top in the AI world at any given moment, all based on which models are winning these direct showdowns. Which leaves us with one final, really important question to chew on. As we rely more and more on AI to judge itself and on our own gut feelings to pick the winners, are we actually building AI that's objectively smarter and more correct? Or are we just building AI that's gotten really, really good at telling us exactly what we want to hear? That's the challenge we're facing. Thanks for tuning in.